In the introductory tutorial on stoichiometry, you saw that mole ratios are key to the stoichiometric relationships that exist. And maybe even more specific to that, balanced chemical equations are what are used to determine the mole ratios that exist amongst the substances in that balanced chemical equation. So if we take a look at the reaction given here, this basically says that for every 2 moles of iron that react, 3 moles of copper sulfate are needed to react with it. And when that reaction takes place in that ratio, 1 mole of the iron 3 sulfate will be produced and 3 moles of copper will be produced. Now the question here says that if we happen to have 5 moles of iron and it reacts with basically all of the copper 2 sulfate that we can have, how much copper 2 sulfate is needed to react with that 5 moles of iron? And so we can use a mole ratio to help us with that. And we set up the mole ratio by establishing on one side of the ratio what I call the known ratio. And so this is the information that comes from the balanced chemical equation. And so we know that we're dealing with iron and we're dealing with copper 2 sulfate. And so we need the information for the known ratio related to iron and copper 2 sulfate. And that is what we see here. So it says for every 3 moles of copper 2 sulfate that react, which is this value right here, 2 moles of iron are required. And on the unknown side of the ratio, we place our unknown. And so I've got X moles of the copper 2 sulfate because that is, as the question states, what we are trying to find. But we know that we are trying to find out how much copper 2 sulfate is needed to react with the 5 moles of iron that are provided. And so both of those values go on what I call the unknown side. And so we're using the given information, which is the 5 moles, and the required, which is what the question is asking for. And so all we need to do now is solve for x. And so we can rearrange this equation in such a way that we solve for x, and you should get approximately 8 moles of copper 2 sulfate are needed to react with the 5 moles of iron. And of course, this makes sense. We would expect that if in the equation here for every 2 moles of iron, you need 3 moles of copper 2 sulfate, then if you have 5 moles of iron, we would certainly expect more than 5 moles of copper 2 sulfate to be required, and somewhere in this vicinity of between 7 and 8, which is what we get here for our answer. And so now in part B, we are taking a look at the amount of solid copper that's produced. And so that's this product here in the balanced chemical equation. And so, of course, our mole ratio here, our known side and our unknown side, both sides need to include the copper, which is what we are looking for, and the iron, which is given. And we see our known ratio. It says for every 3 moles of copper, 2 moles of iron are needed. And so for every 3 moles of copper that are being produced, 2 moles of iron are required. And on our unknown side, of course, we're going to place copper in the numerator, so that we need copper in the numerator, iron in the denominator, iron in the denominator. So both sides of your ratio have to be set up in the same way. And so we have copper in the numerator because copper is the unknown that we're trying to solve for, and it just makes it easier to put it in the numerator instead of the denominator. And we place our given piece of information, the 5 moles of iron that we have, and that will allow us to, when we solve this mole ratio as seen down below, that will allow us to find the number of moles of copper that are produced when we have that much iron. And if you note that the 8 moles here is the same as the answer that was given in part A for the amount of copper sulfate that was needed to react with the iron. And the reason that is because the iron and the copper sulfate from part A were in a 2:3 ratio, and from part B, the iron and the copper were also in that same 2:3 ratio, meaning that in both cases we started with 5 moles of iron, and so we will end up with approximately 8 moles of the copper 2 sulfate for part A, and 8 moles of the copper for part B. So hopefully this tutorial has given you a sense of what the role of mole ratios are in stoichiometric calculations, but maybe even more specifically, how to correctly set them up so that they can be used properly in stoichiometric calculations.